Okay, so let's start. It's 12:30. So hello everyone and welcome to the monthly Café talk, the July session. Thank you for joining us today, and I hope you have your coffee with you to drink it together. So if we look a bit on the menu of today, we will have a very nice presentation from Erika van Herpen related to the AI to the rescue, a novel approach to measure plate leftovers. And after that, we will have some time for the testing notes, and then you can ask your question or comment and start the discussion on this topic. We will also ask you to leave your tip to us at the end by answering some Slido questions. And then we will present the next month's specialty, actually the specialty that we will have prepared for you for September, because we will have a summer break. And with this, Erika, now it's to you to start with the coffee of the day.
Thank you very much. Let me just take a minute to share my screen. There we go. Oh, that went a bit too fast. So what I wanted to talk to you about today is a paper that we have that's called AI to the Rescue, a novel approach to measure plate leftovers. It's joint work together with Maaike Moren, who's from the VU University in Amsterdam, and she is our AI expert. And also joint work with Mariam, Nina, and Melanie, who are all from Germany, but from different places in Germany. And what we wanted to do in this study is to see if we can find a good way to measure food waste that is, well, accurate and not so costly and easy to use and can be scaled up. So let's take a look. We all know that measuring food waste is not easy. It's gained increasing attention. I won't bore you with the details of how important measurement of food waste is, assuming that this audience all knows that. And also that it's important to find ways to make more systematic measurements that are precise and easy to administer. And if we look at the tools that or the methods that we typically use to measure food waste, then diaries, surveys, and waste audits stand out as the most often used. But they all have their advantages and disadvantages. As you will know, surveys, because they rely on self-reported measures, tend to be to underestimate quite drastically. Diaries give a better estimate, but there's a high dropout rate because it takes a lot of time for people to fill it in, and then they drop out. Waste audits are more accurate usually, but they are more costly. And we're now looking at another method, and that's built on photographs. Now, photograph coding has been looked at and seems to be a valid measurement, but it has its downsides as well. So when you think of it, all these methods have ups and downs, and we're trying to find something that can be scaled up, that can be done at low cost, that can be reliable, and still have a high validity and a lot of details in it. Now, when it comes to photographs, we think of photographs like these, photographs of plate waste. These are all examples from photographs in our data set of what people have left on their plate and what they're wasting, left over. And we want to measure what's on there. Now, there's different ways to do that. And traditionally, people have looked at ways with annotation, where they either train a model to learn automatically what's in the image, or they train researchers to annotate manually. So the latter takes a lot of time, of course, and researchers actually need to spend quite a bit of time to code each of these photographs. And that's one of the reasons why it hasn't been used that often. But also when we train a model, that is quite costly. You need a labeled data set annotated by trained researchers in order to train that model. And then every time if you collect new images that really differ from the old ones, you need to increase that labeled data set. So again, you need to have trained researchers to annotate those photographs. So that's all very time intensive and quite costly, therefore. And we thought, like, maybe there's easier ways to do this. So in our approach, we don't do any training of the model. We just use GPT-4o and see whether that works. How well does it do? We compare versions of the prompt that we give to this AI to see what prompt actually gives the best results. And we compare also different measurement units that we can use in those prompts, and other versions that we can provide extra information to the prompt. And then we analyze and categorize the results. So we look both at the correlation between the actual weight waste that was depicted on the photograph and what is estimated by the AI. We also look at the actual ingredients that the AI recognizes and whether that could have been on a plate or not. So we have 2 studies that we did for this. And in the first study, we have a data set of 816 photographs of meal leftovers from HelloFresh customers. So all the people in our data set are HelloFresh customers, but not all the photographs are from HelloFresh meals. These customers actually photograph plate leftovers, weigh these plate leftovers. For the HelloFresh meals, we also know the recipe that they used for it, but they did not only photograph HelloFresh meals, but also meals that they made from scratch or convenience meals that they bought. These people come from 6 different countries: Belgium, Canada, Germany, the Netherlands, the UK, and the USA. So it's a quite diverse data set that we have here. And because we not only have the photographs, but also the weight of the waste on those photographs, we can then compare what AI thinks is on the photographs in terms of amount of waste to those weight measurements. And because we also know the recipe for the HelloFresh meals, for those meals, we can also compare what AI thinks is on the plate, the ingredients that it recognizes, to the ingredients that actually went into the meal, to see whether it actually picks up the right ingredients or is hallucinating on what is on the plate. So in terms of data, we have a HelloFresh box where people follow the recipe. We also have the traditional meals with purchased ingredients. And we have convenience meals such as takeout or frozen meals. And all of these, we have different pictures of them. Next, we developed a prompt. We looked at different measurement units. We asked the AI to give us indications in terms of spoons or cups. We asked to give a range of roughly between this minimum maximum amount of grams that was on the plate and a point estimate. And we compared the prompts. We also provided the AI with additional information. So either a recipe name, just the name of the recipe, the full ingredient list, what type of ingredients went into the recipe, or even the ingredient quantities, like how much of the ingredients was used to make this meal. And the latter, the ingredient list and ingredient quantities, we only have for the HelloFresh meals, obviously. A recipe name we also have for other meals. We asked participants to provide that. And this is our best performing prompt. It asks AI to report all the ingredients visible on the plate, and for each ingredient to give a point estimate of how many grams there actually is on the plate. We ask it to assume a standard dinner plate size of 10 inches, which is a USA-based dinner plate. To use JSON format, we try different formats, and this really is important to have that format come out to make the text that we get, the output that we get, not a descriptive text, but really specified ingredients and amount. Also important is to say that if the AI does not detect any ingredients, to report visible remnants, for instance, also remnants 0 grams, because some cases people report back that there is no dinner waste and they provide a picture of an empty plate. And then if you don't give these types of instructions to AI, it will tend to hallucinate and provide information that's simply not on the plate. Here's a couple of examples of what we then got back when we gave this prompt to the AI. So on the left, we see leftovers with rice, ground beef, carrots. Seems to pick up quite well what is on that plate. On the right, a bit more difficult plate, perhaps to see what's on it. and it comes back with the ketchup and the ground beef and the roasted potatoes with estimates of how much it roughly is. So it seems to work well, but let's take a look at what comes out of the full data set. Here you see pictures with correlations between the grams that are reported on the horizontal axis and the grams that are predicted by AI on the vertical axis. The green dots are represent cases where the estimate is pretty much on target. The the red dots represent estimates where the AI is under predicting how much is on the plate, and the blue dots where it's over predicting. And you can see that it works quite well for the different meals. So there's correlations of 0.53 for the meal boxes, but already higher for the traditional meals, 0.69, and highest for convenience meals, 0.73. The reason it's higher for convenience meals is probably because these meals typically tend to have just more easily recognizable components. So this will be like fries, for instance, that are on a plate, and that's easy for AI to recognize. Whereas the meal box meals typically tend to be composite meals where different ingredients are put together in a single dish. And then from the leftover, it's far more difficult to recognize what is actually on there and how much is on there. What we've also find is that when we add recipe names, that it improves somewhat, so that has a little bit of effect. If we add ingredients, it doesn't do that much, and adding quantities actually risk an overestimation. So if we provide AI with information how much of different ingredients went into the meal when it was cooked, sometimes it just takes up those amounts in its answer back of what's left on the plate, and then it's very much an overestimation, of course, because it doesn't take into account that stuff got eaten. So better not do that. In terms of what is on the plate, AI is also pretty accurate, but then it becomes much more accurate if you provide the ingredients. We also did a second study, and that's because we didn't quite trust our participants completely. So we wanted to see if we could get that correlation up even higher if we were more sure about the actual weight of what was left on the plate. So now we have 4 experts, that's 4 authors or friends of authors of the paper, reporting on 93 meals using 12 recipes. These are HelloFresh meals. So in the households of these experts, the 3 recipes were being cooked, and everyone in the household, 10 people in total, ate from this. We made 3 photographs per meal, one halfway through the meal when there was another one when there was about 3/4 of the meal consumed, and then when people were finished. It could also be an empty plate, but could also be a little bit left over. And then we weighed those plates very precisely, also individual plates. That was a surprise to me, actually. I thought that my plates were all the same, but there's quite a bit of difference in how many grams each individual plate weighs. So we did it very, very carefully to have very accurate measurements to compare AI against. Our results show a confirmation of the insights from the first study. We also saw higher correlations between predicted and observed grams. So our more accurate measurement of the weights actually ensured that it was closer to what AI predicted. So AI was really good in this case, and part of the somewhat lower correlations maybe in study 1 were due to people not weighing correctly or not weighing precisely enough, probably. In this second study, we also gave AI information about the accurate plate size. So we didn't say, well, we had 2 versions, one where we just said, like, assume a plate size of 10 inches, like we did in the first study, but also a version in which we gave it the actual size of that specific plate on the photograph, and that did not really increase correlations. It did decrease somewhat the overprediction on individual cases. So it helps a little bit, but not that much. So our conclusions and discussion then, we conclude that if we use AI for photograph coding like this, of leftover plate leftovers, it's relatively easy to use, but also valid and reliable. It estimates quantities and also recognizes ingredients quite well. And it's a relatively low-cost way of coding these photographs. It's also immediately available to people because you don't have to do any training. There are certain requirements for the data that goes in. Respondents have to photograph a single plate. We had some pictures in the first study where respondents had multiple plates on a photograph or a pot and a plate, and AI has more trouble with that. So you really have to give clear instructions about just photographing single plates. The recipe names are not really needed for quantity estimates, is what we found, but ingredient list drastically improves the recognition of ingredients. So with our ingredient list, AI is almost 100% accurate in identifying what could be on the plate. Without the ingredient list, somewhat less. And then for future research directions, we said that it would be nice to look at other types of food waste other than plate waste, because now we just looked at plate waste, and also to examine consumers' willingness to actually provide photographs like this. In the first study, people were quite willing to provide several photographs of their dinner plates. But if you would ask them to do it multiple times or for a prolonged period, we don't know how they will respond. So that's something for future research to examine. So that is roughly what I wanted to share with you about this study. Here's my contact information, but also the email address of the first author in case you want to get more information. But of course, you're very welcome to ask any questions that you may have. And I'll stop sharing so that we can see each
Okay,
other.
perfect. Thank you very much, Erika. This is a very nice presentation, and this is a very nice work because this brings forward the measurement of food waste on a plate. So I think this is very interesting. Are there any questions or comments from the audience that we have today? Do you want to share something with us?
I see that someone is asking for a copy of the slides. I think I can do one better because we have the working paper online somewhere. I'll check where it is and put it in the chat so then you can really look at the details also.
Yes, and this session is live streamed on YouTube, so you can always go there and watch the presentation every time you want. So, and then you will also see the slides. So I think this is also of use for those that want to share this. Anyone who has a question?
Yep, if there's
Yes,
no one
Sophia,
to
please.
ask, I will have some questions. Like, because you showed the R of your predicted graphs in the first study, but not in the second. How much did you improve that? Because the ones that we saw, they are quite low. So my question is, how about the accuracy of the method?
Let me just take a second to see what the correlations were. They were around 0.8 or so, I think, if I remember well. But if you give me a second, I'll give you the actual amounts. Let me just see. Oh. 0.85 I see here, I think. Let me just... Yes. So it ranges between 0.73 and 0.86, depending on exactly what prompt and what information we give it. So around 0.8, most of the ardents.
That wasn't very clear for me, at least. Maybe I lost something that you said that in the first study, the second study was more reliable, more trustful people. So, and I think and in the end is because of the weight of the waste that was there, and not because of the plate that was not the weight of the plate that was not taken from the measure. It was what I understood.
In both studies, we asked respondents to just give us the weight of the actual ingredients, so to subtract the weight of the plate. But in the second study, because we had only experts doing this, and we ensured that we measured each individual plate, we're more sure that that went correctly. So in the first study, it was just, average consumers doing it. Some may have made a mistake there, accidentally also included the weight of the plate, or some may have inaccurately given us the gram estimates from the weighing scale. So we know that in that study, it has many more pictures, of course, more than 800, but there might be some that are a little bit off. We also noticed that ourselves, if we were looking at some of the pictures that were had a different estimate, that were like outliers based on AI versus the picture, and you look at it and we said like, I actually trust AI more than I trust what the respondents said. So that was our sort of inspiration to do the second study, where we were more sure about that measurement.
But the problem is, like, in the end, you saw that there was no, it was not very relevant, the weight of the plate. Is that what confuses me?
No, sorry, the size of the plate was not very relevant. So we did two things. So we subtracted the weight of the plate always, and that is very relevant to do, because that plate is heavy and it will affect amounts, of course. But what we have is sometimes there's smaller plates, sometimes there's bigger plates. If you give the photographs to AI, it has to sort of deduce what's on the plate, but it might think that a big plate is actually average size or so, or may make a difference. So we tried to do that with the second study with two prompts. One was to just assume that it's an average size plate, but then some plates are bigger, some plates are smaller, so I don't know what AI will do. And the other one was where we gave it, we measured exactly how the diameter of the plate, and we gave that to AI for each individual plate, like this is the diameter of this plate, and now estimate the waste amounts. There we did not find a lot of differences. So it's not really necessary to know the diameter of the plate, how big it is, for AI to make accurate estimates of weight on the plate. It is, of course, important that if you compare to actual weights, the AI will not take the weight of the plate will not include the weight of the plate. It will just give you the estimate of what is on the plate. And to compare that accurately, we need to have measures of just the food waste and not the plate itself. And that's also what we asked participants to do in all of our studies.
Okay.
Yeah. Does that clarify?
Yes.
Yeah. Okay, good.
Are there any other questions? Or maybe I can ask. Okay, we have some question in the chat. Is it needed for consumer to distribute the food evenly on the plate before taking the photo, or to take into consideration different layers?
Yes, that is another thing that we did find, that if food was piled on top of each other, or if something like bigger, like a piece of bread or so, was covering part of the food, then obviously it becomes very difficult to estimate. So that was also something that we found in some of the outliers, that that becomes more difficult. That not something that we can blame AI for. I mean, also for the human eye, it just becomes more difficult if something is covering the plate or if the food is piled up. So yes, that's another thing that we would advise you, if you want to take this further, to ask consumers to not pile the food onto each other, but to distribute it a bit across the plate. Yeah.
Yeah, and my question was also related to the consumer burden. If you have any feedback, like, because I'm thinking of me, if I would be able to take part of this kind of study, what's the effort that the consumer need to do, or you know what I mean? Like if they say this is too much, or how can you improve this or make it easy to use for the consumers?
Yes, and of course you have to realize that for this study, because we wanted to see how well AI is doing, that's why we needed the measurements of also the weight. And that's quite intensive, of course, for consumers to have to weigh the plate with the food waste and without the food waste, and give us those measurements. But if you apply this, knowing that AI is quite good at this, then all you really need is the photographs, and that's it. You can ask respondents to give recipe names. That makes it slightly better. If you want to know the ingredients on the plate, asking them for ingredients is also helpful. But that's, of course, more burdensome for consumers, and we have to see whether they're willing to do that. But just having pictures of the plate already gives you quite a lot of insights from AI coding.
Yeah, then we just promise them that it will get easier in the future.
Yeah. So
I
in the
think.
future, it might just be take pictures of your plates and send it through an app or something, and done. Yeah, still then I don't know whether people will always remember to make pictures, whether they won't forget, but that's something for future research. We don't know yet.
Yeah. Okay. Thank you very much. If you have any other comments or questions, please put them in the chat, because now we need to go to the tip. Yeah, we also need a tip today. So take your phone and try to answer the slide of Sophia.
Okay, thank you. Please, I would like you to engage in our small tip. And let's start. Just scan the QR code or go to slido.com and write the code there. And please start to describe in a word your take-home message. This hallucinating word is making me think, what is the hallucinating? The method?
I think the AI.
Or the scientists? We don't have anyone participating? Only 8 people? Minita, help me here because I'm not seeing the
Yeah. We have 13
total.
people with 2
We have
participants
2
typing.
more typing, please. This is really important for us for our end report, and we really appreciate and thank your help on this small tip. I will wait for the last participant typing. Then thank you very much. So let's go move to the well, now I want to move and I can't. Okay, so now just how do you rate Monthly Café Talk second edition so far? And it's the last.
The last question, not the last monthly
The
Café
last,
Talk.
yes, the last question. It's not the last Café Talk. It's true. I'm expecting the 2 other participants. We had 10 before. Please, one more. Okay, thank you very much.
There it
Minita,
is.
you can continue.
Yes, just I can continue just to announce the summer break, which we are all waiting for. And then we will come back in September also with extra monthly Café Talk. So we will have 2 Café Talks in September. The first one will be on September 12th. And we will have a presentation from Martinie Vollbrecht, if I say correctly. And then we have the extra Café Talk as a special request from Chorizo Project. They ask us to give them the opportunity to present their results in the monthly Café Talks. And this is very interesting. And the presentation will be about the new developed appraisal tool that they did in the Chorizo Project. And it will be on September 19. Again at 12:30, and now I will also put the link for this monthly Café Talk in the chat. And with this, we wish you all a nice summer, and we will be happy to have you back again with us on Fridays at 12:30 for the monthly Café Talks organized by the WASTELESS Project. Thank you very much for all of you for participating. Erika, for the nice presentation.
Thank you very much.